This lesson in our unit on volume is going to cover problems that involve using multiple solids, such as spheres, cones, and prisms and cylinders. And we're going to use their volumes in different ways to solve problems that are relevant to real life. So let's take a look at this example here. Can this cone hold a melted ice cream scoop? So we have two things we need to think about. The fact that this ice cream cone is in the shape of a cone, and also that if you put a scoop of ice cream on top of it, you would be talking about a sphere. What is the volume of the sphere that would be the ice cream? So let's find the volume of the sphere that would be the ice cream. We do that by using the volume of a sphere formula, which is 4 times pi r. In this problem, our r is 1 cubed divided by 3. So 1 cubed is 1. So 4 times pi times 1, then all divided by 3, comes out to approximately 4.19 inches cubed. Let's find the volume of the cone. The cone's volume is pi times r. R again in this problem is 1 squared times the height, which is 4, all divided by 3. So 1 squared is 1. So now we're doing pi times 1 times 4, all divided by 3. And I come up with 4.19 inches cubed. We also can see that in the problem we actually have all the same pieces. So it is possible for a sphere of ice cream to be scooped on top of this cone and then to melt inside. In our next example, a cylinder and a cone have the same height of 6 inches and a radius of 3 inches. If you fill up the cone with water, how many times can you pour it into the cylinder? So we need to find two different volumes. What is the volume of the cylinder? And what is the volume of the cone? And then once we find these two volumes, we'll see how many times the cone volume goes into the cylinder volume. So cylinder volumes are found by doing pi times radius squared times height. 3 squared is 9, so we have pi times 9 times 6. We come out to approximately 169.6. Now let's do the cone. The cone volume is done by doing pi times radius squared times height, all divided by 3. So the volume of the cone is done by squaring the 3 first, so that's 9. So pi times 9 times 6, all divided by 3. Comes out to approximately 56.5. So now we're going to take these two volumes and divide them. So how many times does 56.5 go into 169.6? And it goes in about 3 times. And if I hadn't approximated this, I think it would actually go in perfectly 3 times. In our last example, we have this silicone ice tray. It's it's that flexible, rubbery material. And it's 6 inches long, and it's 3.5 inches wide, and 2.5 inches deep. Each ice cube freezes into a perfect 1 inch cubed. How much silicone is used to make the ice tray? So let's label our picture with this information we have. We know that it's 6 inches long. We know that it's 3.5 inches wide, and it's 2.5 inches deep. So let's first find the volume of the whole thing, not considering the fact that there's all these divider lines that hold the ice cubes apart, but let's find out how much the entire shape, if it were completely empty, would hold. So that would be finding the volume of the prism. So this is our ice tray volume. So it's a prism, so that volume is going to be length times width times height. That'd be 6 times 3.5 times 2.5. I get 52.5. Now we have to find the volume of each ice cube. So this is the actual ice. The ice are formed into cubes, and their volume is they are a perfect 1-inch cube. So that would be 1 length, 1 width, and 1 height. Comes out to exactly 1 inch cubed. But since I have how many of these? Well, let's look at the tray. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 by 5 is 15 ice cubes. So I'm going to times this by 15. So all the ice together is 15 inches cubed. So if I want to find out how much silicone is used, I should take the volume of the total ice tray and subtract out all the ice, and that would leave me with the material that's left of the silicone. So 52.5 minus 15. And I come up with 37.5 inches cubed of silicone. So these are just a few examples that get you into the idea of thinking about using volumes in combined ways, in ways that we can add, we can subtract, and divide in order to figure out what the material or volume of certain kind of situations are.